Good morning. Welcome to our first video lesson for algebra this year. Hopefully there's not too many. We are working on, it says graphing a line. I should say graphing a parallel line. We're doing parallel lines today. There's your 24. We might have done these numbers before, but hey, it's good practice. So pause it, try it. So one for sure here is 3 times 6 plus 2 plus 4. If you find any others and you want to share them with me, feel free to. It's going to be a little hard to ask questions right now because this is a recorded video, but ask them informative. I'm checking it often throughout the day, throughout the week. Don't hesitate to ask for help. And then going forward with this video, a couple of notes. So when you watch a video for math class, it's not the same as watching it as any other YouTube video of like Dude Perfect or whatever else you kids are watching these days, video game run-throughs or TikTok dances. You want to make sure you're engaged with this video. So what I mean by that is that you're pausing it, you're writing down the notes, you're taking a moment to see what did I do and think through what steps did I do and how did I get my answer. If I have an example, I would try and do that yourself, pause it, try and do it yourself. And then once you get stuck or once you get your answer, play the video and see how I do it and then compare. That's going to be much more useful than you just sitting there watching me do my math. So make sure you're pausing it a lot. Quick little vocab review. So for lines to be parallel, that means they do not intersect. In math, especially in geometry, next year we get pretty specific about what a line is. In common vocabulary, a line's just like some painted on the wall that has a finite amount. In math, lines go on forever. The ones that are finite that don't go on forever, we call line segments. But here, these are lines that go on forever. Parallel means those two lines will never cross. So we've got some examples here. All four of these lines are parallel to each other. You'll see they're increasing at the same rate. So for lines to be parallel, it means they have the same slope, but different y-intercepts. Now the question is, why do you think different y-intercepts? Well, if they had the same intercept, y-intercept, they would be the same line, so they would intersect everywhere. So for parallel lines, they need to have the same slope, which is what you see in this column here for all these beautiful colors, and then different y-intercepts. All of these numbers are different. You'll notice, and I kind of covered it up here, these two are the same lines because the y-intercept is 0, so you can just write y equals 2/3 x. But all of these lines would be parallel. So that means if they got the same slope with different y-intercepts. Same idea, this time it's negative slopes, but I just wanted to show you the other direction. These would still all be parallel. They would all have the same slope there, negative 3/4. So that means for each one of these, if you found a point, so there's a point, we go down 1, 2, 3, over 1, 2, 3, 4. And we get our next point. And we could do that over and over and over to find all the nice points on that line. Same with the red, same with the blue. So far we've been learning how to describe a line using a slope-intercept form. As I have written there, y equals mx plus b, where m is our slope. Slope just tells us how much to go up or over, or up or down, and then over, rise, over, run. We also call that change in y. So how much does your y value change between 2 points over the change in x? And then when y has a coefficient of 1, x has a coefficient of m, that's just fancy talk for what we have written here. Technically, there's a 1 in front of that y, so that keeps this equation how it's supposed to be. Then we've got another way called standard form. So standard form is written like this: ax plus by equals c. The coefficient of x is a instead of n. The coefficient of y is b instead of 1. And then we've got the variables on the one side and the constant c on the other side. So slope-intercept form may have fractional coefficients, right? If you think back to the last couple of slides, we had -3/4 or 2/3. Standard form, a, b, and c all need to be whole numbers. Now you can write the equation of a line with both slope-intercept form and standard form. They're going to look different, but it's going to describe the same line. Just like when you have fractions, if you have 1/2 and 2/4, those both describe the same amount, right? You get the same amount of pizza if you get 1 out of 2 slices or 2 out of 4 slices. You're still eating the same amount of pizza. So to change this to standard form, remember standard form is ax plus by equals c. First thing I'm going to do is I don't like fractions, so I'm going to clear out the fractions here. We've got y equals 4/5 x plus 2. I'm going to multiply everything by 5 here. I multiply by 5 because that's our denominator. When I multiply this by 5 here, the fraction is going to clear out. So we got 5y equals, we have 5 times 4/5x, but as we see, we got 5 on top and 5 on bottom, so those cancel out. So we're left with 4x plus 10. We did 5 times y, 5 times 4x, or 4/5, and 5 times 2. So then we would have 5y equals 4x plus 10. And we can subtract 4x from both sides. Got a little sloppy there. So we would have -4x, because x goes first, plus 5y equals 10. So this line, if you graphed it, and this line, if you graphed it, would be the same line. The key is to clear out all fractions and decimals to make it all whole numbers, and then put the x's and y's on the same side of the equation. So go ahead and take a moment to try and do this one. So this one's pretty straightforward. You just add 2x to both sides. And you get 2x plus y equals -1. Here we've got y equals 5/3 x. So I'm going to multiply everything by 3 to clear that fraction out. So we get 3y equals 5x. Subtract 5x from both sides, and we get -5x plus 3y, that's a bad y, equals 0. So now we're going to go backwards. We've been doing slope-intercept form to standard form. Now we're going to go from standard form to slope-intercept form. Remember, slope-intercept is y equals mx plus b. So a couple of keys here is the y is by itself. We've got a coefficient for the x, and then we've got a value for the y-intercept. So we're solving this equation for y. So I'm going to subtract 2x from both sides. You always want to start, if there's possibility, with subtracting or adding. 2x minus 2x, it's like you have $2, you take $2 away, you got no dollars. So we have 3y equals -2x plus 6. And then we're going to divide everything by 3. And we get y equals -2/3 x plus 2. Notice I wrote -2/3 x. I didn't write a decimal. I didn't put 2x over 3 because -2/3 tells us if we're graphing this, we start at 2 because of our y value. And then we go down 2 to the right 3 for our next point, down 2 to the right 3 for our next point. So we want to keep that as a fraction. Take a minute to try this one. So first step, move the x to the right side. We get -2y equals x plus 4. Divide everything by -2. And we get y equals -1/2 x minus 2. This 1 came from, because there's a 1 in front of that x. We don't put it there because we don't need to, but there is a 1, so you're doing the 1 divided by the -2. So that's why there's a -1/2 x. And then a positive divided by a negative is a negative. Add 3x to both sides. We get 4y equals 3x minus 8. Divide everything by 4. Y equals 3/4 x minus 2. So then we're going to do some practicing of graphing with both the y-intercept, the slope, and standard form. So we are told to plot the points -1, 4. So we go to the left one, then up 1, 2, 3, 4, and then 1, 0. And we want to find the slope intercept formula and the standard form equation of the line. So if we look here between these 2 points, we can count the slope. We start on the left point, we go down 1, 2, 3, 4, over 1, 2. When we go to the right, it's positive because the numbers are getting bigger. So the slope, our rise was -4. We went down 4. Kind of weird when I say rise negative, but rise is just kind of a term for going up or down to your y value. Over 2, -4 divided by 2 is -2. So that means we have a point every down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, which means we also can now say our y-intercept is at 0, 2. So we would have y equals -2x plus 2 for our slope-intercept form. Our standard form, we would add 2x to both sides, and we would have 2x plus y equals 2. -3 would be here. 3 + 1 would be here. So we would count up 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6. So our slope, remember it's y over x, so it's 4 over 6. Reduce that by dividing top and bottom by 2. We get 2/3. So then we can find our y-intercept. We go up 1, 2 over 1, 2, 3. Up 1, 2, 1, 2, 3. So our y-intercept is at 0, -1. We're going to have some more precise ways to find the y-intercept in a couple of lessons, but right now all of these should be nice ones that you can do with the slope. So our slope-intercept form is y equals 2/3 x, because 2/3 is our slope, minus 1. Our standard form, we're going to multiply everything here by 3. So we get 3y equals 2x minus 3. 2/3 times 3 is 2. And then subtract 2x from both sides, and we get -2x plus y equals -3. Subtract 2x from both sides here. There's your homework list. Remember, don't hesitate to ask for help or any questions or clarifying questions on the homework this week on formative. See you guys in class whenever we meet, Wednesday or Thursday. I forget.